Good morning, Nana. Only four members are there. Ashwita, who is there? Give the response. I'm audible or not? Remaining who? Ashwit and remaining two persons? Sritan. Okay, good morning. Next one. Chinmay. Okay. What happened, Nana? So many are there. Six members are coming now. Saiti. Okay. Ashwit, Sritan, Chinmay, Saiti. Okay, groups. Today we will discuss an objective concept, that is groups. So let us take some one example. Okay. Number of ways of dividing 10 people into groups of 6 and 4. Okay. Number of ways of dividing 10 people are there. Suppose let it be 10 people into groups of 6 and 4. Let it be some people, 10 people are there. So making into groups of 6 and 4. So let us just we draw like this rough diagram. So some people are, one group is four people and second group containing six people. First group, second group is 4 people. Okay. So that is the number of ways they are asking. The number of ways of dividing 10 people into groups of 6 and 4. How many number of ways are will come? So out of 10 students, we are selecting a group. Out of 10, we are selecting the group means 10 C6 ways. Okay. And then out of remaining, how many we are there? Remaining 10 people, 4 people are there. This is a selection means it is also selection remaining 4 people out of 4. Then we are selecting in 4C4 ways. Okay. Here remaining out of 6 minus 10 minus 6 means remaining 4 people. From 4 people we are selecting in 4 these. This can be done in 4C4 ways. So okay, remaining are people are 4 and selection is also same. So out of 4 units we can selecting 4 people, that can be 4C4 ways. So this can be done in formula is 10 factorial by n minus r factorial, that is 10 minus 6, that is 4 factorial into 6 factorial. This is only in 4C4 means how many ways? NCN. NCN means one way. So therefore the total arrangements is 10 factorial by 4 factorial into 6 factorial. In rough diagram we can say directly what is the basic formula. By observing the figure we can get the answer by total number of persons are 10 dividing by 6 factorial and then 4 are there 4 factorial. Directly we can write as The number of groups of dividing 10 people, 4 and 6 is directly we can write as a rough diagram. That is 10 factorial by 6 factorial into 4 factorial. Nana, please inform to your friends. This is already objective concepts, Nana. What you are doing in the home, just you will inform to your friends. Shervani is there, Akhilesh, Rishabh, Saiti, Chinmayi, Sritan, Hashvit. That's all. Manvita is, where is Manvita? Remaining, all those. Himagna. Similarly, second example, directly we can add, as per figure, just in people are there, make into 6 and 4, directly the answer is number of ways equal to 10 factorial by, okay, 10 factorial by 6 factorial into 4 factorial. In the same way, second model example directly makes a groups nothing but out of 10 people who are selecting 6 people, then the remaining 4 people can be selecting out of 4 in this unit as 4. So it can be done in 4C4 selection. So directly we can draw the figure, then we can write as 10 factorial by 6 factorial into 4 factorial. Suppose second one is number of ways of dividing 10 people into groups of 5, 3, 2. The size of a group is 5 and the second group size is 3. Third group size is 2. So rough diagram we can write 10 people. So group size is 5 and 3 and 2. So the groups of 3 groups. Then we can write out of 10 people divided into 5 group. One group is 5 group. Second group is 3 members group and third group is 2 people. So this can be written as our convenience. In previous example we can write as total number of arrangements as 10 factorial. Then we can write as first selection of this out of 5 selection is 10C5 into remaining how many? 10 minus 5. Okay, 10 minus 5, 5. In the out of 5, remaining 5, from these 3 we are selecting, then this can be done in 5C3 ways. Out of these values, totally 5, in this remaining again how many members? 2 members are there. From these 2 we can write as 2C2 ways. Okay, the number of ways of selecting the groups of 10 people, 5, 3, 2 is, first we can select by 10 by 5 people. Then in the ways of 10C5. Next remaining 5 people are there. Out of 5 people we are selecting 3 people, that is can be done in 5C3. And then remaining 3 people are also come over, 8 people are remaining, selection is over. Then the remaining people are 2 people are remaining. Out of people we can selecting this group as to 2 people, it can be done in 2C2 ways. Okay, but directly we can write as the directly form as 10 factorial by 5 factorial into 3 factorial into, okay, solvation we can do. Solution directly we can say, but solution before that we can write the proof. So 10C5 nothing but how much? 10 factorial by 5 factorial into n minus r factorial, that is 5 factorial. And again 5C3 nothing but 5 factorial by 5 minus 3 factorial is 2 factorial into r factorial is 3 factorial. Into 2C2 is obviously how much? 1. Now 5 factorial cancel. Then the remaining is 10 factorial by 5 factorial, 5 factorial into 2 factorial into 3 factorial. This is the total number of ways. As per proof methodically 10 factorial by 2 factorial into directly we can say that the shortcut is out of 10 people 10 factorial, the groups are the size 5 factorial and 3 factorial into 2 factorial. Directly answer we can say that directly. Okay. In the same way we can treat as a formula for grouping. The formula is the number of ways of dividing m plus n distinct objects into two groups of sizes m and n is, before the example wise, the number of ways of 10 people, total value is 6 plus 4. So m plus n, that is equal to 10 into two groups. Two groups nothing but we can write as m is the size is m and another size is n is how many number of ways we can get already all those 10 factorial by 6 factorial size of the value. Let it be m, let it be n. So a total value by factorials. So the formula is m plus n factorial divided by m factorial into n factorial. This is the formula. So out of m plus n things, we can make into groups of sizes m and n is m plus n factorial by m factorial into n factorial. So this is the formula. That is nothing but m plus n total overall group. This can be divided into m group and n group. Then we can say that therefore the number of ways is m plus n factorial by m plus n factorial by m factorial into n factorial. Similarly, second formula. Just now we have applied this formula based. Similarly, third group, three groups. So the number of ways of dividing m plus n plus p distinct objects into three groups of size m, n and p is, just now we have learned formula number of ways of dividing 10 people into group size 5, 3, 2. Directly this selection is as per explanation is this. Indirectly we can write as total by group size factorials. Same thing as to this m plus n plus p, that is the formula m plus n plus p overall total value divided by group sizes m factorial into n factorial into p factorial. This is the formula. So, if n plus p distinct objects are there, groups can be divided into the size of m, n and p is nothing but m plus n plus p factorial by m factorial into n factorial into p factorial. This is the value for groups formula. Suppose the groups here is all of the groups of here all of unequal sizes. Here is unequal sizes. Sizes are different. 6 and 4, 5, 3, 2, M and P. Here M and unequal sizes formula we can write directly as per example, and formula is like this. If suppose groups of equal sizes are there, the groups may be division is groups of unequal size and equal size. Okay, but equal sizes is there. So let us take one example first now. So number of ways of dividing, suppose let it be 4 people are there into groups of 2 and 2. Number of ways of dividing 4 people into groups of 2 and 2, let it be. In previous example, the groups of unequal sizes, but here the formula is to write in the form of Just formula we can derive by using the example. So let us take one example, that is number of ways of dividing the groups into 4 people into the groups of 2 and 2 equal sizes. So rough diagram we can draw. 4 people are there. So make it to divide, then it is 2 and 2. So from out of 4 we can select 2 persons each 2. And the remaining how many? 2 remaining. 2 remaining in this group we can select in 2C2 ways. And then we can write this value as 4 factorial by 2 factorial into 2 factorial. This is as to 1. But dividing with the 2 factorial, this is not a correct way. That is, the answer is goes to 4C2 into 2C2 by 2 factorial. Why I am writing 2 factorial? Why I am writing 2 factorial? That is equal groups are there. So what else? Suppose let us take A, B, C, D. Why we are writing 2 factorial in the terms of down position? So A, B, C, D, let it be some friends are there. So two people, that is let it be AB, and another group is CD. Next another case is CD and another case is AB. So how many ways totally? Two ways. So make into two ways, that it be divide with the 2 factorial. If it is equal group, so then we can divide with the group as to total by 2 factorial. So total by 2 factorial. Therefore, number of ways, why you are writing two ways, nothing but make this ways will come. If it is two equal groups are there. So that is why 4 factorial divided by 2 factorial into 2 factorial into 2 factorial. Next, same thing as to another example, example 2. Number of ways of dividing, number of ways of dividing 6 people into groups of 2, 2 and 2. For rough diagram, 6 people, the groups of sizes is 2, 2 and then 2. So correct number of selection asked for first group is 6C2, 6C2, 6C2 ways, and then from this remaining 4, 6 minus 2 means 4, 4 people remaining. From these 4 people we are selecting 2 persons. This can be done in 4C2 ways, and then totally 6 plus 2 remaining, here we can get only 2 people, that is 2C2 ways. So this can be total things can be done in as per figure 6 factorial by 2 factorial into 2 factorial into 2 factorial. But how many group of people are there? So 3 groups are there. Then we can divide with the 3 factorial. Then it is correct solution. Okay. So how many groups are there? We can divide with the, if it is 3 equal groups are there, then we can divide with this. Why? Because 6 group of people are there. Suppose A, B, C, D, E, F. The first group is AB and second CD and EF. This is one of the group. And then AB, EF and then CD will come. If it is CD, the group will start. Then we can write AB and EF. And another group will can form CD, then EF and AB. And next goes to the EF group and AB group and CD. Next group is EF and CD and AB. And all are similar with the same group A, B, C, D same. But two things are repeated. Then totally we can get 6 ways. 6 ways nothing but how many ways? 3 factorial. So that is why we can divide with the group of equal size nothing but divide with the 2, 3 factorial is must. This is total we can get 6 factorial ways, but same thing we can repeat it. So repeated means total number of ways is 6 ways. So then we can repeat it with the 3 factorial. Okay, this is the example. Then we can write the next example directly. The group of people are 12. Then it is goes to number of group sizes are 3 3, and let it be 2 groups, and then another group is 2 and another group of size is 2. Then number of ways equal to, what is the number of ways we can write? Total number of ways equal to total divided by how much, Nana? 3 factorial into 3 factorial into 2 factorial into 2 factorial into 2 factorial. And then how many groups are there? These are the one group. This is the one group of size, equal groups. So let it be how many groups? 2 groups are there. So then we can multiply here 2 factorial. Okay. Next 3 similar groups, equal size. So this 3 groups are there. Then the value becomes to here divided by 3 2 factorial into 3 factorial. Then it is correct. Otherwise it should not be correct. Therefore the number of ways of dividing 12 people into groups of 3 3 2 2 2, nothing but. So unequal size means don't divide with these values. But equal groups are there. How many groups? How many groups we can equal groups or unequal groups make into 2 groups, nothing but. So in this similar equal groups 2 are there, and then 3 groups are similar. So divide with in denominator 2 factorial into 3 factorial. Then we can write a formula, important, that is number of ways of dividing 2n distinct things into groups of size n is n each is 2n factorial by n factorial into n factorial into 2 factorial. Another form is number of ways of 3n objects into 3 groups of size n such that the value of the formula number of ways equal to 3n factorial by n factorial into n factorial into n factorial into 1 by 3 factorial. Formula: number of ways of dividing 2n object things into groups of size n and n is 2n overall factorial by n factorial into n factorial into 2 factorial. This is the formula. Equal groups, nothing but total value is becomes to 2n factorial divided by group of sizes n factorial, second group size is n factorial, then multiply with 2 factorial. So 2 ways will come. So similarly three groups are there, then we can get 6 ways. So that is nothing but 3 factorial. So the last term we can write as into 3 factorial. Second formula: number of ways of 3n objects into 3 groups of size n such that formula is 3n factorial divided by n factorial into n factorial into n factorial into 1 by 3 factorial. Here 1 by 2 factorial. So this is the formula. So 3 groups are there, then we can divide with 3 factorial, And if it is equal groups or two equal groups are there, we can divide with 2 factorial. Three groups are there, we can divide with 3 factorial. Suppose here number of, let it be this examples, you can try. Okay, this is the formulas based on groups. Okay, next geometrical representation. Then you can write geometrical representation. Nana, give the response. Are you understood or not? Ashwit, Rishabh, Akhilesh, Shravani, Manvita, Himagna, Chinmayi, Akhilesh. Where is Vaishnavi, Sahiti? These are all objective concepts, Nana. If it is two groups are there, divide with 2 factorial. And Ramana is there. Okay. Next formula we can write. The heading is geometrical applications. These are all concepts belongs to objective. Don't waste the time. Please revise all those. Try to example problems in textbook backside questions. All are this type of questions only. Practice this time. In afternoon session we have free now, so you can try yourself. First one. What is the geometrical applications means? There are totally n points in the plane. Exactly p of them are collinear. Then the number of straight lines that can be formed by n points is the geometrical application. Okay. First you can write the first formula. There are n points in a plane. There are n points in a plane. Exactly p points of them are collinear, then the number of straight lines that can be formed by using these endpoints is, the formula is NC2 minus PC2 plus 1. Okay, let it be some, what are the question conditions is given. In a plane we have, let it be some endpoints are there. In the endpoints, exactly p points are collinear. Collinear means the points lying on the same line. Suppose let it be some lines are collinear. Some points are collinear. Out of endpoints, some p points are collinear. Collinear means the points lying on the same line. So some points are collinear. Then how many number of straight lines that can be formed by using the endpoints? Totally we have endpoints. To make a straight line, we need to write out of endpoints we are selecting in C2 points. Why? Because straight line makes 2 points is enough. How many points we can, number of ways is nothing but NC2. Out of P points are collinear, so that it be how many points we can get out of P points. We are selecting a 2 lines, that is PC2. But out of these points collinear nothing but this is the common point of M points and P points. So let it be, we are doing the by addition plus 1. The formula is NC2 minus PC2 plus 1. Number of total points we can get the value as we using the endpoints. The basic formula is NC2 minus PC2 plus 1. Why you are doing addition? Out of m points and p points, one line is common of both the points. So let it be by adding this point totally. Then we can get the value as NC2 minus BC2 plus 1. Next formula, second formula, geometrical application. Second one, there are m points in the plane. P of them are collinear. Then the number of triangles can be formed is, there are n points in a plane. P of them which are collinear. P of them which are collinear. Then the number of triangles that can be formed is, so totally how many points in the plane we have already. So by using the triangles we have to use, whereas before that if it is a form a straight line we can get any 2 points is enough, but n points we have. So totally how many we can select means NC 3 points we can select, but in these P of them are collinear. Collinear means it cannot be exist as a triangle. If triangles are non-collinear, then we can draw a triangle. But it is collinear means we cannot construct a triangle. That's why we are doing minus PC3. P means collinear. Collinear points are how many? P. Triangle formation means PC3. So we can subtract totally NC3 minus PC3. This is the formula out of MC3 minus PC3. These are the formula, whereas there are n points in a plane, P of them which are collinear, then the number of triangles that can be formed is MC3 minus PC3. Okay. Next formula, a set of m parallel lines. This how many lines are there? M parallel lines are there. And another lines are intersected by another set, nothing but these are how many are there, let it be n another parallel lines. Then the number of parallelogram that can be formed is, so number of parallelograms, that is to write how many out of m points we can any one selected. Suppose we can select 2 points, that is out of m points we can select 2 points, and another lines we can select as another 2 lines. These are these, or these are these, or else these are these into NC2. So total number of parallelograms formed is MC2 into NC2 points. Then the number of parallelogram formed. What are they? A set containing m parallel lines, another set containing n parallel lines are intersected by the another set n parallel lines. Then the number of parallelograms can be formed is MC2 into NC2. The total number of parallelograms are this. Okay, next point, fresh lines. There are n lines in a plane. No two of them are parallel and no three of them are concurrent. The new lines are formed by joining these points of intersection of these lines. Then the number of new lines that can be formed is n into n minus 1 into n minus 2 into n minus 3 by 8. Fresh lines formula, Nana. That is, there are n lines in a plane. No two are parallel and no three are concurrent, then new lines formed by joining the points of intersections of these lines, then the new lines that can be formed is n into n minus 1 into n minus 2 into n minus 3 divided by 8. This is the formula. The fresh lines out of n points. Some points are concurrent, some points are parallel. Then the new lines can be formed by joining this point of intersection of these lines. Then the new lines that can be formed is the fresh lines, or say that formula is n into n minus 1 into n minus 2 into n minus 3 by 8. Okay, from this model, some questions are given in the questions. The question is like this. Question number 1. There are 10 points in a plane. 10 points in a plane of which 4 are collinear. Then how many different straight lines can be drawn by joining these points? Is dash. What is the answer? What is the answer for this question? There are 10 points in a plane, 4 of in which are collinear. How many different straight lines can be joining these points? Give the response, Nana. 10C2, Ashwit, okay. Only Ashwit is doing the. What about the remaining? If they are not interested, yes, super. The answer is 10C2 minus 4C2 plus 1. Plus 1 means all points are overlapped. That is why we can write plus 1. Out of 10 points, 4 points are collinear. 4 points are collinear. Okay. So one line can be overlapped. That is 10C2 minus 4C2 plus 1. Plus 1 means all points are overlapped. That is why we can add one line should be plus 1. Okay. The question is like this. In the same similarly, second one is 6 parallel lines are intersected by 5 other parallel lines. Then total number of parallelograms can be formed. What is the answer? Chinmay, Manvika, Himagina. Why are you going elsewhere? Only 7 members are present now. Ramana, Khilesh, Rishabh, Sritan, Sahiti. Yes, 6C2 into 5C2. That's all. The formula is MC2 into NC2. Then we can write the formula.